Give me 1 minute, it's just starting. Give me 1 minute, it's just starting. All right, Professor, we are live.
Good evening and welcome to everyone, and apologies for this 7-minute delay. We are very happy to have with us Mr. KP Singh, who needs no introduction because he has already given us a very nice feedback on the previous NACDeC. Just for the record's sake, I only want to say that he is a retired chief designer of Hindustan Aeronautics Limited and has played a very, very major role in the development of this lovely aircraft. So, Mr. Singh, we will give the floor to you now, and we will allow you to engage us on the evolution of Tejas, India's LCA. Over to you, sir.
Thank you, Professor Pan. Thank you very much for the nice words. And without losing any time, we'll start today's talk on evolution of Tejas, India's light combat aircraft. Let me start this talk with a riddle. Can anybody guess which aircraft is this? I know many of the audience, I expect them to be younger lot, and they may find difficult to find out which aircraft is this. So I'll tell you the answer. This was the first supersonic jet fighter from India. HF Marut. That's what it was called. And if we see the bit of technical details and history of this project was launched in 1956 and induction into the Air Force 1967, and it retired in 1990. And totally 147 numbers were built. 147 is not a small number. And it's just let me see. It's I'm having a bit. Where is my presentation gone here? Once presentation has vanished.
No, we can see it, sir.
Achha, no, but you can see the presentation.
Yes, slide number 2, very much there.
Achha, I'm seeing. Achha, my view would have changed probably.
Maybe your view has changed, but presentation is very much there.
Okay, so I should see the gallery or gallery view.
Sir, I would request you can stop sharing and share one more time. That would fix your view.
Okay, stop sharing. I do that. Stop share. And then one more share. One more share. Okay, now what do I do? Share. Well, yeah, but yeah, it seems to have failed. But I'm not seeing the full screen, my own screen. On the right side, there is a view of Padna, Dr. Pant, and myself, the videos.
No, don't worry, sir. That is not a problem. That is just a matter of detail. So don't worry.
That's okay. No, we can see your screen very well, sir.
No, that's okay. But I need to read from this corner. No?
So, sir, what I request you, if you have your presentation, you could very quickly just email it to Professor Pant or myself, and we will share it from our end, sir.
Okay, I'll do that.
But why is it needed?
Sir, because Dr. Singh is not able to see the slides himself. We are able to see it, but the view is such that he is not able to see it.
No, I am able to see, but only the right corner where your photos.
So you can minimize that part.
Just ignore that, sir. Just ignore that and continue. Just ignore that and continue. That is just a display thing.
Okay. Now you are able to see now.
Yes, sir. You
Yes,
can just go into the slideshow mode and it will be perfect.
just press F5. That's it. Just do that and we'll be ready. Yes, we are
Perfect, sir.
ready.
All good.
All good. You can
All,
start.
all good for you, but I'm still not seeing the right corner. That is the problem. Anyway, I think that's some view problem. My view is set to something else. Anyway, we can continue. So these are some details of the Marut. So you can see the problem with this Marut was it was underpowered. See, India couldn't get a proper engine required for this. So it was underpowered. It did do some good service to India in 1971 war. It was deployed on the Rajasthan border, but nevertheless, it wasn't a success aircraft because it was underpowered and we could not get any proper engine for it. So engine, remember, is a very critical link in this fighter aircraft. So now come to the Tejas. Any project, what's its name, of the level of complexity as Tejas, it starts with some requirements from the customer. And the requirements in Tejas case came from, obviously, Indian Air Force. Now, these requirements, so-called specifications or the targets which need to be achieved through the design of this aircraft, these targets or specifications are not 5-6 lines or a few lines. A good number of some 25-30 pages report comes on the requirements, and the requirements not only describe the quantitative parameters, performance parameters, but they also go on to systems details, weapons requirement, and overall project requirements. So what we are seeing is some of the basic requirements, which are basically essentially quantitative, like what's the maximum speed required, what's the maximum rate of climb required, how much should be the service ceiling, what should be the maneuverability, what should be the turn rate. So you are seeing all these figures, and if I may draw your attention to a couple of important figures in this, one of them seems to be turn rate. Turn rate LCA requirement was 18 degree per second sustained and 30 degree per second instantaneous, or we call it attained. It really became one of the critical requirements from the thrust required point of view, from the aerodynamic efficiency L by D required point of view. Similarly, there is a requirement called max roll rate. So you must have more than 270 degree and combat radius of more than 500. So these are the requirements. Of course, max speed was required more than 1.6 Mach, and in dive they expected, which is generally 20% higher, 25% higher than the max level. So that would be of the order of 1.8. So these were typically the performance requirements. Now let's come to the mission requirements. So all the performance requirements, what we saw, most of them were sort of point performance. At a given point, some Mach number, altitude, you are expecting it to have this much turn rate, or at sea level, this much climb rate, or max speed at so and so altitude. Mostly they are point performances. Apart from that, there are just some sort of mission performances which you come across in the form of range requirement, endurance requirement, or field performance, takeoff, landing, etc. Now, all that is, all those are very routine performance requirements, but for fighter aircraft, there have to be specific requirements for the missions it is supposed to do. So for LCA, what you are seeing on slide, it is a multi-role, multi-mission aircraft. So Air Force wanted it to play the following 5-6 roles: air superiority, close air support, interdiction, deep penetration, escort, combat air patrol, etc. So this becomes another set of performance requirements, and for each of these profiles, they will give a 1 page of details, with a proper diagram of the mission and segment-wise flight details, at what speed, what acceleration, what altitude, what has to be done. So each mission will be specified in a page. So ultimately we'll get some 10 odd pages for mission specifications. Then they go to the systems. See, that's not enough for them that it does this performance and this missions. There are systems requirement. For example, they would like to have flight controls, which should be with fly-by-wire, avionics, all modern avionics, NVG compatible, glass cockpit, HUD, MFD, HMDS, AES, radar, etc. Then a host of armaments. They will give the list. They want to put CCM, MRM, BVR, ASM, AGM, what all you can think of, they would have specified. And they may not specify on the day one they issue the requirement. It keeps getting added, every 4-5 years they will add some, this store also is required, this missile also is required. And that story continues, late in the development, and even for Tejas. Today it's continuing. We are trying to integrate Astra missiles, or even the BrahMos. No, this thing goes on throughout the life. Then there are specific requirements about EW switch. See, EW switch has a very critical role in fighter aircraft. See, it is the survivability issues. You can kill, you can destroy enemy only if you can survive yourself. So whole lot of electronic warfare, let me say, the subsystems are available, like RWR, MOAS, CMDS, SPJ, jammers and IRST and all sorts of intelligence. So they want that. Propulsion system, yes. Single fuel turbofan. See, they specify that it should be single fuel turbofan engine. Undercarriage, type of undercarriage requirements. They look at the simulator requirements. They want not one simulator, not two. They want many simulators. For example, training simulator, flight and mission simulator, real-time simulator, Iron Bird, and so on. And then there will be special system, in-flight refueling, OBOX, de-icing, ejection seat, all sorts of things, brake parachute, etc. So you see the this whole set of requirements, very, very extensive, exhaustive requirements, And yeah, and we look at the last bit of the requirements, which are overall project oriented. So they will specify, we have a fleet requirement of 200, for LCA it was 220. And when do they want to induct in the Air Force service? That time, when they wrote these specifications in 1985, in 10 years, they wanted to induct. And they said, okay, preferably 1995. Then Uh, then how much life they require? 30 years, calendar life, fatigue life, 5,000 hours. And look at the documentation, operation manual, technical specifications of aircraft, its systems, user manual, maintenance and repair manual, LRUs list.
That's okay.
And all sorts of things. Then ground sport equipment, spares, airworthiness, flying quality certification. Who will do your certification? They will accept SEMILAC and DGA, QA. And what are the airworthiness guidelines? Probably they will say, whatever we are giving as air staff requirement, that is basic and followed or added by a mil specs. So you put together and meet the airworthiness requirement. And then they want after sales service, maintenance, overall infrastructure to be set up at the manufacturer premises. So I have tried to summarize these requirements in 4 pages, what you are seeing. But actual document is anything between 25 to 30 pages. So you can see they are asking the best possible aircraft through their specification. Now, how do they formulate these specifications? See, who tells them that you ask for rate of climb 200 or you ask for turn rate more than 18 degrees sustained? See, it's a question is they look at our, the aircraft threat perception, what our neighbors have. So if our neighbor has F-16 or Chinese have some aircraft, or first thing they will look at it, they want a capability better than those aircraft. And secondly, whatever they already have, for example, when we had, when LCA started, that time we had a big contingent of MiG-21 in our inventory. So obviously they will look at that we are trying to replace this MiG-21, so we should have a much better aircraft. So they take the best of everything. They take the best of rate of climb of maybe Mirage and best turn rate of F-16 and best speed of maybe MiG-21, and we'll put together all the best and they will say, this is what I want. So this is like saying, I want moon. So what is the problem in that? That problem is that whatever they want, such a bird probably doesn't exist, or it is not possible to make everything best in one aircraft. So the bargaining starts. So the design team will do some studies and come out, I can meet this, I cannot meet this, I do this, I will not do this. This is possible, this is not possible. So some reports are submitted, the reviews are held. And after a year or so, the customer as well as the designer, they come to some compromise and redefine the final requirement. which may be a little bit, which takes care of designers' point of view that it is not possible to meet. If you try to meet this, it is not possible to meet the other. So some compromise is set up and some revision is done to the original requirements and new requirements are issued. And that's what happened in LCA also. Now, what happened when the government sanctioned the LCA project and the whole aerospace industries in India was in deep slumber after the HF-24 design. And there were naturally the birth pangs. Given the project requirements, now Indian teams started having birth pangs. Where to start the design? How to start? Who will take the lead? How to get up from the years of slumber and execute such a challenging project? And to their good luck, the solution came from the government itself. They formed an organization called ADA, and they gave a mandate as the nodal agency for LCA development. So the problem is solved. Who has to bell the cat? That is ADA. ADA, what it in turn they did, they contracted HAL and hired HAL as aircraft prime. And then both put together. In the earlier days, ADA, HAL were, we had a wall between us. Our buildings are next to each other. So otherwise, it was always looked at as one unit, ADA, HAL. So ADA, HAL put together, they engaged 4 European companies to do the feasibility studies. So imagine the story that we were not that time equipped well to do even a feasibility study of such a challenging project. Anyway, we gave a lot of crores to the foreign companies, and 4 companies, they did the feasibility study for us. In the meantime, ADA kept extending the collaborations. ADA was very sharp in this, very fast. They tied up with NAL, AD, GTRE, IAF, Indian Navy, Bell, DRDO Labs, ISRO, Academia, IITs, ISC, name it, private sector. They extended their wings. ADA went wholeheartedly, involving everyone. Wherever there was some expertise available, they tried to take him or her on board. So within 5-10 years, Tejas project had established more than 100. Tejas project had sort of established more than 100 work centers across the country. You see the map on the right, it's taken from ADA's publication. And all over across the country, there are people, working on ADA, LCA project. Amazing, it is amazing. And then there were a number of inter-organization national teams. One team was for control law or fly-by-wire. One team was for CFC composites wing. One team was for flight testing. Whole of nations talent was pulled into national teams and they worked together for years to produce this marvel called LCA. Now, These were birth pangs. So when NADA gave the feasibility study to the 4 companies, these 4 companies were British Aerospace, Dornier of Germany, MBB of Germany, and EMDB of France. And put together these 4 people, they recommended following configuration. See, this is the beauty of the design. They have been given same requirement and they have been asked to propose a solution. And they come up with the solution which is at variance from each other. So this is a beauty of design. It's not a closed form equation which can be solved, So one company said, take off-tail configuration. Somebody said, take tailless delta. Somebody says, you take canard delta. So what should we do? Well, Indian team did a fantastic job and they did the normalization study of these 4 proposals. And finally, they managed to select that we shall have tailless delta configuration. And this job was done by our Indian team. So finally, the tailless delta was chosen, and then we went ahead for designing this. Now, I've just put a cartoon which any aircraft design project has this problem. There are multi specialities in aircraft design, and at HAL, even at TADA or any design organization will have a different departments or groups for each specialization. For example, there will be aerodynamics group, there will be equipment group, there will be electrical group, there will be power plant group, hydraulic group, weight group, etc., etc. Now the trouble is when these designers from these groups, when they look at an aircraft and their vision is what this cartoon is showing. See, somebody who is an aerodynamics fellow, he looks nice, smooth surfaces, and what is inside is least concern. And somebody from power plant group, he will see the whole aircraft looks like an engine with a propeller. And somebody with the from the electrical group, he will see all the looms and wires and cables and some dabbas. For him, wing, tail, all that has no meaning. He has some fuselage, he will put everything cabling. So various groups, various designers, their perception about their own work is as if this is the only aircraft design. So it takes a bit of time. See, if they keep blowing their own trumpet, you cannot make a meaningful aircraft. So somebody has to harness, not only harness, somebody has to mentor their thinking so that they appreciate each other, because without appreciating each other's work, it cannot be integrated into a good design. So this process had to be gone through for LCA also. LCA was no exception. Now what happens when somebody has given you a requirement and you have accepted to do the design? So what is the first step? We all know. We have to find out how big the aircraft should be, how powerful the aircraft should be, the size and the power. That is the first thing we want to know, which will be required to meet those requirements. And that exercise All of you have read, and maybe many of you have done it. It's called constraint analysis. So initial sizing and constraint analysis was done for LCA. Same way like you do for any aircraft, big or small. So you have a modeling of all the requirements of speed or rate of climb or turn or takeoff, landing, everything, all requirements which you are supposed to meet, they can be expressed in terms of T by W and W by S. And then you go on and put on a chart T by WS by W by S, and you find a design point. And that design point means that if you select corresponding T by W and WS, then you will meet all the requirements. Very, very simple it looks. Fine. So for LCA, that exercise was done, and it's not done once only. In the initial years, things are very fluid. You select one engine, then somebody says, let's try the other engine. So you keep redoing, or some requirements, some concession is given. So this keeps happening multiple times. And for LCA, when it was sufficiently frozen, the solution came as a T by W is equal to 0.91, W by S 245. So from there we worked, weight was that time 9350. So we wanted thrust of 84 kilonewton and a wing area of 38 meters square will do the job. Now then you scout for 84 kilonewton thrust and you find G404 engine is available. Fine. But at the same time, government wants we should develop an indigenous engine. Okay. Then the project was given to GTRE, development of Kaveri, which you all know, the history. So the Kaveri's specifications were around the thrust requirements, what were worked out from this constraint analysis. So Kaveri must have similar thrust to the GE engine. So that's how the Kaveri specifications were set and project was launched and went on for 25 years. Still, I think it's going on. It's unfortunately that Kaveri, I will come to a little later, that it has produced, I mean, there have been so many gains from that engine, which people are refusing to look because of a single failure that the afterburner thrust was supposed to be 80 plus kilonewton and they could achieve only 72 or 73 kilonewton. So since that shortfall was there in their afterburner thrust, it could not be deployed on LCA. So everybody looks, Kaveri lowly, which is not correct. It has produced so many good things, which I'll come to later. Anyway, engine was selected, and this is the engine parameters comparing GE and Kaveri. So basically, you should look at the two parameters. That dry thrust requirement of LCA was 54 kilonewton. And Kaveri was also set to design for 51 kilonewton. And wet thrust with afterburner was required was about 85 kilonewton. And Kaveri was also set to around 80 plus kilonewton, but it could achieve only 73. But it achieved the dry thrust. Don't underestimate that achievement. Kaveri has achieved the dry thrust, what was required or what is GE giving. So we are at par with GE as far as the dry thrust is concerned. The problem has happened in wet thrust. And I don't know, God willing, it may be sorted out in future, or even if it is not sorted out, the Kaveri developed so far will be very, very big asset for Indian aviation or aircraft industry for future projects. And one of them is right knocking at the door, Ghatak. And there's a UCAV UAV project, combat UAV project being done at AD, and they are going to use dry engine thrust, dry Kaveri engine. It's a big, big yield. They are going to use Indian engine, which is Kaveri. So forget, yeah, we couldn't meet, or Kaveri couldn't meet LCA requirement, but it is by in itself, it is a good engine. It is giving so much thrust, and many future aircraft will use this. Fine, we go back and come to Tejas airframe and system. So the aerodynamic configuration of Tejas was made tailless compound delta. It had relaxed stability, static stability. Relaxed static stability, sometimes people call it unstable configuration. And when we say unstable configuration, we mean statically unstable. Don't confuse it dynamically unstable. We are not dynamically unstable. Statically unstable, which we will use a control law and automatic flight control system to make it stable. Now, powered by a single fan bifurcated Y duct, we have V tail, vertical tail, rudder, aileron for pitch and roll control. See, there is a same surface, ailerons, which do the function of elevator and aileron. So put together, they have been named as ailerons. Then we have leading edge slats, canopy is raised, tricycle undercarriage, and 8 hard points. Now, similarly, at the system levels, you have extensive use of composites, you have integrated avionics, digital flight control, EW system, OBUX, in-flight refueling, integrated flight control system, so many armaments, etc. All state-of-the-art system. And the look of the three views is in front of you. Fantastic looking, cute bird. Yes. So why did we go for unstable configuration? What was the need for that? See, this is a conventional stable configuration where there's a wing body lift and tail lift, and there's a net lift, and AC is behind the CG. This is conventional stable. An unstable configuration like LCA is where lift from the wing body. There is no tail anyway, so lift from the wing body is a lift of the aircraft, and that is ahead of CG, so it is unstable. But what happens in trim when you want to fly trim for a stable configuration? See here, you will have to deflect tail down to create a down lift so that you can balance the pitching moment which is coming from wing body lift. So when you create down lift, the total lift on aircraft reduces. So it will be wing plus body lift minus tail lift. So net lift on the aircraft will be reduced. But if you do see the same logic on unstable, you will have to deflect the tail. In this case, in place of tail, we have to deflect the aileron down, which creates uplift, and that gets added to the wing lift, and that total lift becomes more. So what is the net benefit of making it unstable? The total lift, or you may measure it in terms of L by D, which is aerodynamic efficiency of the configuration, that will become more. And what other benefits you have? Unstable configuration. Number one, you have higher trim lift. Number two, you have more agility. Unstable means you little bit touch it or pilot gives small control. It will maneuver very better, higher maneuverabilities. Carefree handling you can do. But what is the price you have to pay? You cannot fly unstable aircraft without having fly-by-wire system. A fly-by-wire system becomes a must. And that involves technology, that involves cost, development, effort, etc. But yeah, you want to reap you are on the edge of the technology. You have to fight the fighters who are, very close to the performance we are trying to achieve. So you have to be a little bit ahead of them. And that little bit ahead is coming from such concepts called unstable configuration. So we went for unstable configuration and went for fly-by-wire. Fine. Now look at the air intake design for Tejas. The design features are bifurcated wide duct design, boundary layer diverters, splitter plate, and optimize the contours. And the design drivers are always quantitative, which is mass flow requirements, Mach number at the compressor face, etc. And qualitative requirements, quality of flow, whether it is a separation free or what is the swirl, what is the distortion level, and supersonic intakes has a buzz problem, so you have to make buzz free design. So it looks a very simple thing, some duct you are making which is diffusing and trying to feed the engine the mass flow it requires. But when you really want to do it, especially the quality part of it, the distortion and swirl and buzz free, it's not a simple job. Now for LCA, most of the intake wind tunnel model testing was done in France. And it was not 1, 2, 3, 4 model. Many more models were made and tested and optimized intake, and the story went on for good 7, 8 years. So, it's a concurrent engineering. Other systems are being developed. So you don't feel that only intake has taken 7, 8 years, because it's concurrent. A lot of other things going on, at the same time. So that is intakes. Now, look at the amount of wind tunnel testing that has been done. Mind-boggling. It is mind-boggling. I have summarized. I have been party to many of these wind tunnel tests. And I have summarized what all we have tested. And you see the type itself, the type of wind tunnel tests: force and moment, surface pressure, external store, intake, dynamic stability, rotary, free spinning tests, and many more. And so many models, so many test facilities, and many of them are abroad. And what all data we brought, millions of data points, and brought and analyzed and then used in the design. And look at what I have written below: total wind tunnel testing effort on Tejas. It is estimated in total that about 20 test campaigns were launched on 15 plus different models at about at about 10 wind tunnel centers over a period of about 10 years and generating over 4,000 plus polars of data. It is massive. It is massive. You won't believe. And it has cost crores and crores of money to make models, to book facilities in USA, France, Russia. ADA didn't leave any chance, Let's go anywhere, anywhere, best facilities in the world and test LCA and make sure that we have a real good data, exhaustive, extensive, fantastic. So if only you look at this wind tunnel testing done for LCA, you will realize why these projects are taking, tens of years to fructify. Let's see the integrated flight control system. So LCA has, the state-of-the-art integrated flight control system. You have set of sensors, you have actuators, you have computers, you have recordings and displays, and everything is integrated into one. They work in harmony, in unison with one each. So fantastic system, and these are the various components of this integrated flight control system. Similarly, there is integrated avionics system, and again, a wonder. Look at what all has been integrated. I mean, it will take a lot of time to read it out, so I'll avoid that. But there are displays, there are various avionic functionalities, all have been integrated into a wholesome avionics system. Look at the radar today. Today, as of date, everyone talks of ISA radar, which is the in thing, which is the best thing in the world. And LCA has managed to develop that for itself. And soon, I think on Mark 1A, it will be integrated, or if not Mark 1A, Mark 2 definitely. And this is fresh from the oven, designed by LRDE, and now one private company is making it. And it has all the, hi-fi specifications, best in the world. And, all the time, India kept, longing for ISA radar, ISA. Now we have our own. Now, electronic warfare, what is this system? It is basically survival system, and it has three components. You have electronic attack, you have electronic support, and you have electronic, I can't see this, electronic protection. Okay, so earlier these names used to be different, they used to call by different name like ECM, ESM, etc. But essentially there are jamming technology or confusing or misleading enemy system. Then there are sensing and analyzing enemies, threats and communication. And then the third is defending friendly systems. So whole lot of subsystems are there in each, and LCA is occupied with one and all. We have not left anything, everything is there. Of course, it has taken time, it didn't come in LCA Mark 1. Everything didn't come in Mark 1. So there are a lot of things came up in Mark 1A, and a few left will be put in Mark 2 also. And then we'll have the best EW system in the world. This Tejas EW system is called by our indigenous name called Swayam Raksha Kavach, SRK. Please don't read it as Shah Rukh Khan. It is Swayam Raksha Kavach. And this SRK includes ECM, ECCM, ESM, all the names you have ever heard in the context of EW system. Now coming to the ejection seat, we have a Martin Baker, UK's presently ejection seat, but in future, I'm not saying 100% sure, but maybe we are going to go for the A36 seat. And the reason for change is strange because sometime back there was a export proposal to Argentina, Tejas export to Argentina. And UK, the makers of Martin Baker seat, they objected that our technology you can't give to Argentina. They have some old enmity with Argentina. So India is taking a view, okay, we want to sell our LCA, we'll put Russian seat and sell it. So you may find after some time seat is replaced. Now, this is another marvel. I'm not dwelling too much on systems, but each system has developed in LCA from scratch. And one example I'm putting up here is called ECS, Environmental Control System. See, the beauty is this system architecture, design, development, manufacture is 100% indigenous. 100% means 100%. But the content of LRUs in this system that we started with, the indigenous content was 50%. Then a lot of indigenization went on, and today it is 90% indigenous. And soon, maybe tomorrow, it is going to be 100%. Wonderful. See, from where we have come, and this system, see, we've been buying all this type of aircraft from abroad. And for this system, very high bleed temperatures come out from the 404 engine. When we tap the bleed flow, the temperature is 630 degrees centigrade. And our indigenous design has been made to handle this this type of temperatures in India. Now look at the air conditioning subsystem. It is tropicalized purely to Indian climate and performing much better than the systems available on our foreign acquired aircraft. I remember Wing Commander Kotyal, I'm going to quote here, after the first flight of Tejas in way back in June 2001, he came out and he remarked, comfort-wise, the best among all the aircraft with the Air Force. This is his words. And it was heartening to hear that. And the digital controller for ECS is again 100% indigenously designed, developed. And there has been a development of a test rig for the ECS system. And very, very few countries only in the world have such rigs, test rig. Very comprehensive test rig, and the complexity of Tejas it is able to handle. And then there was a software model developed to assess the system performance of Tejas. That software is still being used by our newer designs, IJT, HTT40, and now currently it is being updated for MCA project. And it will be used for the MCA project. So it's a wonderful example of system level indigenization done in LCA. There are other systems also, but for want of time, I am unable to put system by system. Now look at the weapons and look at the figure on right. So we have 7, 8 stations and name it, all the missiles, all sorts of bombs, all sorts of uh, LGBs and drop tanks and whatnot. And of course, internal gun and all those things. So host of weapons are there. And mind you, the mission of any fighter is not to show off as we show off in air shows. See, you go low level, zooming and climbing and all that. All that drama is not part of, not the role of fighter aircraft. What fighter aircraft is made for? Destroying the enemy, killing the enemy lines. And for that, you require weapons. And your weapon power is what defines the worth of a fighter aircraft. Even if you have to fight in the air, you will have CCMs, close combat missiles, and internal gun and things like that to shoot other aircraft. So you have to be equipped with variety of stores and lethal stores, and LCA has it. Yeah, this is continuing with the store and the stores. Modernization is, continuous. We are still, today also, we are integrating Astra, then we'll do some Rudram or ASP. All this will go on. It will continue further also. It's not going to stop. So this is Tejas inboards, and at some stage, this is how Teja looked. Now also, below the skin, if you inboards is nothing but if you rip off the skin, and what you see below is called inboards. So fantastic inboards you can see of Tejas. Now simulators. As I told earlier, so many simulators have been made, successfully used as design tools. See, this is another beauty. Tejas has used the simulators, not like post-development as flight simulators, not for that. We have used the simulators as design tools. And there's a variety of simulators which were made, and some of them are reproduced here. One was a real-time simulator done at ADE. And in this picture, in fact, Dr. Kota, the chief designer of LCA, he is sitting in the real-time simulator and flying it. I had a video, I don't know, it will play. Yeah.
Yeah, sir, video is playing very well. Video is playing.
That this was Dr. Kota. Now on the right is Iron Bird at HAL. See, as the name suggests, it is made out of iron, and it has the same, sort of shape and paths of systems are integrated on this iron structure, and it is given commands from from a cockpit, and all these systems, they work in real time, as they will deflect the surfaces with the actuators and all that is real actuators are, integrated. Fantastic facility at HAL Ironbird. There's a full mission simulation. There is this is another great simulator, engineer in loop simulator. This is done at NAL, developed, and it was used extensively as a design tool by the controller developers and engineers. And then there's a training simulator, variety of simulators, and all professional. Coming to the materials, extensive composite materials have been used. 45% composite structure by weight and 85 composite structure by surface area. Surface area, you can see this green, gray, yellow, even this green, they're all composites, this gray is basically carbon composites and green is glass composite and yellow is Kevlar. And small white you see somewhere, that is aluminium. So surface area wise, it's very difficult to find aluminium. Yes, weight wise 45%. So it is by any standard, it was state of the art materials. And this, how many you see, I have listed down how many prototypes were made and used in the development. See, we had two technology demonstrators, TD1, TD2, and then there was a prototype vehicles, PV1 to PV6, 6 of them. Then there were limited series production vehicles, LSP2, LSP8. So if you put together, it is some 16 prototypes. Mind-boggling it is. 16 prototypes have been used in the flight development effort till 2022. And total sortie flown 5,000. And total flying hours 3,250. And number of accidents nil. LCA didn't have any accident in its whole development. Two of the recent accidents happened, one in 24, I think, in Jaisalmer, and one, of course, Dubai Air Show. And that's nothing. That's a mosquito bite. That's nothing. Whereas the aircraft world over, even F-16 or Mirage, or you take any hi-fi aircraft, they have suffered much more accidents. And going by those statistical data, LCA's record is definitely number one in safety. So this graph is from ADA's annual report, and it shows the number of sorties and number of hours. So you can see the flight development effort, vehicle-wise, TD1, TD2, fantastic. Now the technical operations, technical specification. This is just a list of what is the weight, what is the length, size, all that, which is the engine, what is the thrust. Just for completeness, I have put it. And performance, what has been achieved, max speed, max cruise, rate of. Some time back, we saw the specifications given by the Air Force. And here I have put down what has been achieved in LCA. So this is certified achieved performance, which means mostly we are very close or somewhere better, somewhere a little deficient, but it more or less does the job. Now this is a production, Tejas production centers. You see all the production of Tejas has been outsourced to private sector. And I think if you see surface-wise biggest, that seem to be red color wings. And that our L&T is doing, L&T. I hope Dr. Tanvi is there to validate what I'm saying.
Yeah, she's very much there.
Yes, sir, very much here.
Oh,
It's
good,
very
good,
heartening
good.
to see that.
Good, Tanvi, good.
Yeah.
But it's your L&T Coimbatore unit, I think. They are
That-
doing it.
That's right. There is a
Yeah,
dedicated shop where we are building the wings for the LCA along with all the tools that have come over from HAL.
yeah. L&T anyway is doing very well. Of course, I'm sure L&T will be, saying is something, but when you have to really do it, you face the music. So that learning must be going on. If you see the fuselage parts, there is a company called DTL in Bangalore. So they do the front fuselage, and landing gear is done by one company in Kerala, Thrissur, SIFL. Radar is developed by LRD, but I think there's one private company which is making it. Now, only imported pieces here are, one is engine, that is coming from GE, and one is IFR probe. This is coming from Cobham Limited, UK. And third one, of course, is ejection seat. So these are the three components which we can say we have imported and put it here. And of course, a lot of attempt was made to put Kaveri in place of GE, but okay, there's a time for everything. Someday it will happen. So overall, what I can see is HAL has outsourced all manufacturing to private sector. What we are doing is assembly and equipping and direction, and then of course flight testing, production flying. That too, it's not a development flights. The production flights, you make aircraft, and in some 7-8 flights, you will ask Air Force to take it. So anyway, it's a good ecosystem. And this is one example of the first batch of Tejas has been delivered. When it was delivered, a picture was taken at its base. And now coming to the Tejas variant, we have LCA Mark 1, LCA Navy, LCA Mark 2, LCA Mark 1A, and LCA Trainer. Now, all this presentation, I'm not really covering the LCA Navy part, which has been going on, and it's still going on. Of course, trainers, we have made some trainers depending on the order, and they will be made. That's fully developed. But this Mark 1 version is the first version which went into production. And now Mark 1A has started, and I think the last year, October, our Honorable Defense Minister flagged off first Mark 1A from NACDeC plant. And now that deliveries are going on. And maybe in a couple of years, Mark 2 will come into being and some orders will come, and that will happen. And this is the technical comparison of Mark 1, Mark 1A, Mark 2, where what has been made better. Full lot of features I have put to get a complete picture of where do we stand. And there should be, kindly note the point number 10. Mark 1 is aimed to replace MiG-21. Mark 1A also will replace MiG-21. And both put together will replace 220 aircraft. But the Mark II is going to replace It is slated, I mean, still the order has to come, but it is slated to replace Mirage and uh, other, what is that aircraft? Yes, I'm not able to see what is written here. Jaguar, yeah, Jaguar, and one more, I think one MiG series is.
MiG-29, sir.
MiG-29. See, our video is covering it, this part of the slide. Okay, so, but it's a great thing to observe that we are going to replace MiG, Mirage, Jaguar, and our MiG-29 or 25, not 29, sorry.
29.
Yeah. So it's a great thing to see that our indigenous aircraft is going to do that. And let me come to the timeline where we started, how we went, but I'm going to go very fast. See, we have nothing to hide. We have taken longer time than we should have. Yes, I accept it. And there are reasons which at this forum I would not like to talk about, but I can justify each and every delay or whatever has happened to this. This developing a technology of this magnitude, where each system you want state of the art, the best in the world at this time, and that too being developed by people who have been sleeping for years. Suddenly you get up and start developing systems like this, it will take time. You don't know the technology, you will burn your fingers and learn and develop. So it will take time. But there are many other justifications. I will avoid to enter into that. However, let's have a look at what all happened. So the project started way back in 1982, and the official sanction uh, came somewhere in 80, sorry, air staff requirements was this government of India's committee approves the project definition. See this all, so you can say, okay, ADA has been formed in 1984, and 1984 or early 1985 is the beginning of this project, and then this all is going on, and in 2001 we have done the first flight of TD1 on 4th January 2001. And Honorable PM A.B. Vajpayee came and said LCA should be called Tejas. And that's how we got the name Tejas. So that is in 2001. So something like 85 we started and set the ball rolling, and 2001 we have flown. Not so bad. Of course, the further, now you see that this is the first flight, 2001. You see what is happening. 2001 to 2013. This is a single line I have written. This is a flight development. How many years? 12 years of flight development. Total of 16 prototypes are being flown left and right. Something is upgraded with something, something is having some features, and continuous flight development has gone on for more than 12 years. So in 2011, the RSD document was issued by the certification authority. So in 2013, final RSD document was issued. So you can say 13 plus 10, maybe 23 years lag gaya hoga. Now, this development doesn't stop here, it will continue. Like first stages was handed over to IAF. This is 2050. See, that is the first delivery. Now, from there to here, 10 years again have gone. And it is in delivery mode, or it is in further development mode, or version is being changed, technologies are being changed. So don't mix up this period, This is a continuous upgrades going on, and Mark 1 became Mark 1A, and Mark 1A will become Mark 2, and story will continue. So you can't put the whole time frame on LCA and say 35 हो गया, 40 हो गया. ऐसा कुछ नहीं है. It has taken some more time, but it is there are reasons. Okay. Now, what are the takeaways from Tejas project? Look at the big headings. You will not be able to read the smaller text, but big headings are important. Tejas has given birth of. There's some disturbance. It is birth of aerospace ecosystem in India. And mind you, we often keep talking ecosystem for aerospace manufacturing. I'm not talking about that ecosystem. Ecosystem for manufacturing or aerospace manufacturing is sub-part of one element of ecosystem created by Tejas. Tejas is the mother of aerospace ecosystem in India for design, development, and manufacture of technology-intensive, state-of-the-art military aircraft and helicopters. This is the kind of ecosystem Tejas has given to the country. And second, we used to read this Shakespeare's book, Taming of the Shrew. Taming of the Shrew, I remember. So it is like taming of aerospace technologies. ADA and LCA management and LCA team has taken head-on with the technologies and tamed all the hi-fi technologies in the aerospace industry. Call it composites, CAD/CAM, CFD, FEM, internal testing, fly-by-wire, advanced simulator, avionics, ISA radar, HUD, MFD, advanced airborne weapons, advanced system, health monitoring, ground testing, flight test development, name it. LCA or Tejas has not left any advanced technology untamed. Everything has been tamed. And third is Tejas has attained the status of epicenter of Atmanirbhar initiative. See, it is undisputed epicenter of the Atmanirbhar initiative of Government of India. This Tejas is transmitting an earthquake of indigenous aerospace technologies. That's what I call epicenter. See, it is transmitting an earthquake of aerospace technologies at the rate of 7 on the Richter scale. And of course, metaphor is intended. So that's what the takeaways from Tejas. Now, let us see the conclusions. I have 3 slides on conclusions, and this is conclusion 1. And conclusion 1 summarizes the technical worth of Tejas. So we call it Tejas is a homegrown 4.5 generation fighter aircraft. It incorporates all the 4th generation technologies with the exception of none. Its agility, performance, and lethality are at par excellence. It is making rapid strikes to become the backbone of the Indian Air Force. Tejas is a loud warning to the Indian adversaries, threatening them to annihilate them if provoked. So be careful, my dear enemies. Tejas is not going to let you disturb us or provoke us. Conclusion 2, we the team LCA, aka Tejas, apologize to the world, especially the America and the West, for developing a 4.5 generation fighter equally good or even a shade better. You had started this 4th generation race. We are ending it now. Sincerely yours. And here is the partial list of many organizations who have struggled to build Tejas. So this is conclusion 2, and we come to the conclusion. I don't call it final conclusion. I call it the conclusion. The conclusion is in regard to the French Revolution. They say, but for Rousseau, there would have been no French Revolution. And I say, but for Dr. Kota, there would have been no Tejas. Thank you and Jai Hind. Thank you.
Thank you, sir.
Welcome.
Amazing and very motivating talk, which I'm sure has galvanized the interest in the minds of these youngsters who are taking part in this competition. Okay, so many people are sending their positive comments about the talk. We are already out of time, but definitely we can take a few questions. But
yeah, sure.
In the interest of time, I'm going to limit it to very few. So please, if you have any questions, please shoot. Lead of team. What is it? Utkarsh.
Good evening, sir. Am I audible?
Yeah, please go ahead.
Go ahead.
Yes, sir. Good evening. Sir, I want to ask regarding the configuration. Sir, why the tailless delta configuration? And sir, have you faced any challenge? Sir, why?
There's no challenge. See, I had shown you the 3 possible configurations proposed by the foreign experts, and one of them was tailless delta. So when Indian team examined it for the given requirements, if we want to meet, we felt tailless delta will be good. So that's it. It meets our requirement better than other configurations.
It's very difficult at this stage to explain all that because, as you said, the team.
So one more question, can you ask?
Yeah, go ahead.
Sir, in this 30 years of development of Tejas, have there any new requirement came from the Air Force while the development of the Tejas, and how you meet up these challenges from the Air Force?
Not one requirement.
Okay,
during the development, see, the technology is changing. You can't blame Air Force. See, they write requirement in 1985. We start designing. And of course, one reason is they would have expected by 95 we'll start flying. We fly after 10 years. So that is one reason. But nevertheless, for these technology intensive projects like Tejas, technology keeps changing. The weapons, new weapons start coming. Okay. So after 5 years, 10 years, Air Force will naturally say, "Bhai, abhi ye bhi weapon laga do, ye bhi laga do." So many of the requirements, like type of radar you want to put in that. See, that requirement kept changing. No, such things will keep changing. They cannot be helped. So what I call this mode of development, what has been followed by HAL, I have given it a name. I call it concurrent upgrades. See, you have heard of concurrent manufacturing, you have concurrent engineering, you have heard so many things. But I call it was a strategy or which got followed automatically became a strategy. But the concept is happening is during the development itself, you keep upgrading. See, normally you will upgrade when the aircraft is in service. After some years, you will upgrade because technologies have changed. But in LCA, what has happened? We've been upgrading during the development itself. And this is a fantastic concept. I don't think anybody in the world has ever done it, which LCA has done it. As the development is going, of course, the bad part is it takes more time because your development becomes slow. You suddenly change the goalpost, so you start developing. But the beauty is you get a product which is the latest. So depends what you want. Now, I would like to clear one doubt of in many of the people's mind. See, when air chief or any of the great functionary or gurus of aeronautics, when they say somebody is not happy with the LCA, no, they don't say not happy with LCA. Suppose they are not happy with HAL or ADA. See, or they may say they are not happy with LCA also. What they mean is they are not happy with the time it has taken and the slow deliveries it is going on. None of those experts, including Air Chief, has ever told LCA is not a good platform or not good technologically. Has he ever said? No. They say it is a fantastic aircraft. At technological level, it is wonderful. But it has taken more time, and even now deliveries are not coming through smoothly. So please isolate these two things. You have built a wonderful machine, technically very superior machine. We can fight F-16 or Mirage or any of these fourth generation aircraft. No issue. Yes, we have taken more time and deliveries are slow because of various reasons. So kindly differentiate these points. LCA is a great aircraft, great platform. It has given us great gains for the country. Today, if you are able to make a MCA or dream of making MCA, it is because LCA was made. The LCA has given you the legacy of ecosystem under which MCA will be made. So must remember that.
Sir, I'd like to just interject now and say that if you don't mind, you can share your email address so that if anybody has a genuine query, they can contact via email.
Yeah, Pansab, you can share, but I can speak if anybody wants to know.
No, you can speak, and this is so passionate. But the problem is that we need to wind up now. It's okay. Because we are on YouTube Live already. We have gone to more than 1.5 hours.
Yeah.
Queries and doubts will remain, and I think we need to, in the interest of time, and it's already 9:36. I think we need to thank you for such an engaging talk and exciting all of us about our own homegrown aircraft. And we will be sharing your email address on the group, but with the strict instruction that they should not ask you things like, please help us with our NACDeC design problem and all that.
No. Last time it happened, one of the fellows, I don't want to name, he started asking NACDeC product, please help me. I said, sorry, I can't.
Yeah,
I will come in the picture only when you do the project and it will come to me. Then I'll come in the picture.
You will be very much involved in the final stages. They should realize. So therefore, they should not. If they do anything, we will disqualify them. So please let us know, because
sure. No way.
All teams and also all the other people who are there in this group, in this meeting. Thanks a lot, and a very good night to all of you, sir. I'm going to stop.